This is a production of Cornell University.
Okay, so what is a quality soil? Okay, characteristics of a healthy soil: it's got good tilth, okay, sufficient depth, sufficient but not excessive supply of nutrients, small population of plant pathogens and insect pecks, good soil drainage, large population of beneficial organisms, low weed pressure, free of chemical and toxins that may harm the farm or crop, resistance to degradation, its resiliency, as well as resilience when unfavorable conditions occur. Okay, if it has a drought. I mean, you guys just got done doing pot studies. Okay, part of the experiment was how long you guys could keep your corn growing in those drought conditions or under low water conditions. Now, in general, everybody's plant croaked. But some of your plants took a lot longer to die than others. That's a characteristic of the soil that you guys created. Okay, now, if we think about these soil characteristics, soils have both dynamic characteristics and inherent characteristics. Inherent characteristics are those that are, that's just the soil's natural ability to function. The example there was sand. If a soil is sandy, it's going to drain faster than a clay soil. Deep soils, another example here. Deep soils have more room for roots than shallow soils. Make sense? Okay? These are characteristics that are not going to change easily. And in general, from a management perspective, you are not going to be able to manage by changing. You're going to have to manage that characteristics. It's a sandy soil, live with it. Okay? Now, there are also dynamic characteristics. These are things that you can manage change in a reasonable fashion. A good example of this is the amount of organic matter that's in a soil. Okay? How you grow your crops, how you harvest, how you add amendments is going to have a huge impact upon soil organic matter. How you manage it is also going to have a huge impact on soil structure. The water holding and nutrient capacity of soils are often very much driven by organic matter. So if you can manage this, you can potentially manage that. Does that make sense? Yeah? Okay. Now, how do we assess these characteristics? Now, where am I going with this? So let me take a step back for a second. Where am I going with this? Why am I talking about soil quality? Any thoughts here? I set the stage is that we're going to be facing a lot of serious problems coming down the pike. Food being one of them. So why am I talking about these individual characteristics? Any thoughts there? Should I give the answer? Is this is 9 o'clock, please? It's partially management. We have to figure out how we can face these problems in the future. So let's think about the characteristics of our soils that control these functions so that we can then manage these functions for the future. Does that make sense? Okay, so how do we in fact assess how these characteristics are performing or how these soils are performing? It turns out that most soil quality can't really be measured directly. You can't say, well, this is a good soil and this is a bad soil. You can say this is a good soil for rice, this is a good soil for building, this is a good soil for drainage. Okay? But you're not actually measuring a soil, you're measuring characteristics of that soil. So we're looking basically at indicators, certain indicators that give us an idea about how a soil is going to perform. Okay? Indicators are measurable properties of soil or plants that provide clues about how well that soil can function. Indicators can be both physical, chemical, or biological. Useful indicators are going to be things that are easy to measure. Okay? They're going to measure changes in a soil's function. They're going to encompass all of these different properties. They're going to be accessible to many users. It's not going to be this very small group of people that know how to do this. And they're going to be applicable to field conditions. They're going to be sensitive to variations in climate as well as management. Okay, that's what these characteristics need to be, these indicators. Okay? Now, I pulled these indicators from the Cornell Soil Health Initiative. Okay, this is the Cornell Soil Health Assessment Training Manual. And these are basically all different type of characteristics that we measure to give us an idea about a soil's health. Okay, this is not necessarily its soil quality, but it's soil health. And there's a whole bunch of different physical ones, biological ones, and chemical ones. Okay, we're not going to go through all of these, but we are going to go through some of them. Okay, now let's think about some physical indicators. Okay, some physical indicators that you guys know about at this point are soil structure, depth of soil, infiltration and bulk density, and water holding capacity. Okay, I'm going to ask you guys a question. I do expect an answer from this. What kind of relationships or characteristics or features do these indicators tell us about how a soil is functioning? Any ideas? Let's start with soil structure. Good soil structure, bad soil structure. Platy soil structure, blocky soil structure, granular soil structure. Do those things tell you something? Yeah. Okay, what do they tell us? What kinds of things can they tell us?
How it was formed.
How it was formed. Water infiltration and root penetration. How about something else? Biological activity. Granular structure versus platy structure, root infiltration issues. Okay, management, how you are in fact managing it. If you have a platy structure or subsurface, you probably have a plow pan in there. Make sense? Okay? There's a whole slew of potential indicators here. Retention, transportation of water, habitats for microbes, estimate of crop production, compaction, porosity, workability. Okay? These indicators are measures of these characteristics, these properties, these management goals. How about another one? Chemical. These are some that you guys know. pH, EC, extractable NPK. Whoosh, yeesh. I'm trying to talk too fast. What might these indicators tell us? Nutrient availability and toxicity. What else? Biological activity. What else? Parent material. Weathering. Biological and chemical activity thresholds. Plant and microbial activity thresholds. Plant availability of nutrients and potentials for NP and NNP loss. Good examples? How about this one? Some biological ones. Microbial biomass C and N numbers. Potential mineralizable N. Soil respiration. What might those tell us?
Water capacity.
It could tell us about some climate issues. Water. What else? What else? pH. I mean, we can measure that one directly. Nutrient availability, decomposition rates, microbial catalytic potential, repository for carbon and nitrogen, soil productivity. What's going on there? Nitrogen supplying potential, and their microbial biomass activity measurements. Cool? Okay, let's go for a specific one. Soil organic matter. This is one that sort of integrates a number of them. This is both physical and biological. And to a certain extent, I guess it's considered also chemical. What would SOM numbers tell you? What? Sulfur activity? Productivity. Soil productivity. Structure. Fertility. Water holding capacity, water capacity, infiltration. Cation exchange. I think you guys got most of them. Soil fertility, structure, stability, nutrient retention, soil erosion potentials. These make sense to everybody? Okay, so I've sort of driven it home enough. You guys sort of got it all right. So the thing here is that soil quality is not an end in itself. Okay, we're not, you know, the soil. I'm not really too concerned about the soil quality. I'm more concerned about the soil function, and the quality is telling me, in a sense, how the soils are functioning. Okay, The ultimate purpose of research and assessing soil quality is not to achieve high aggregate stability, biological activity, or some other soil property. We use these characteristics as indicators of soil quality, but in the end, soil quality must be identified by how it performs its function. What is it going to do? Back to the big five. Sort of take-home message here. If you think about this, and you think about all the variety of soils that are out there, each combination of soils that are out there and the land use calls for a different set of practices to enhance those functions. Okay? Not all soils the same. And by this time, you guys know that. But now it makes sense.
This has been a production of Cornell University, on the web at cornell.edu.